This is a really cool infinite series question. Why? Because we have n times n plus 1 plus n plus 2 times dot 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 up to n plus 100. We have a total of 101 factors on the bottom. So do you think it's a good idea for us to do partial fractions in the usual sense to take care of this? Do you think it's really a good idea to just write this as some number over n plus some other number over n plus 1 plus dot 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 up to some other number over n plus 100 and hope that this is a telescoping series somehow, since we'll cancel out and we'll get our answer? I don't think so, right? This kind of method works if we have two factors on the bottom. That's ideal. We can do partial fractions. Maybe 3 factors is okay, but definitely not a total of 101 factors, right? However, though, I would like to tell you guys that this right here is actually telescoping in a very nice sense. But before we continue though, let me just review what a telescoping series should be. Ideally, we want to have the telescoping series in this particular form. We want to have a series, let's say n goes from 1 to infinity. Ideally, we want to have just 2 parts. And the first part, let me write it as an, and then we will want to have a subtract in the middle. And for the second part, we want an plus k. This just means that this and that are the same kind, but they are just off by some number, and k is just a positive whole number. So for example, if we have an, let's define this to be, let's say, 2 over n plus 1. And let's say we have an plus k, let's say k is equal to 3. Then in that case, this right here is just going to be, you plug in n plus 3 into here, so 2 over n plus 3 plus 1, which is n plus 4. So you see that they're actually of the same kind, but they're just off by 3 terms, right? But off by 3. So that's the idea. And then if you plug in, you can see the typical telescoping series. And I do have a video on this, especially going over the quick way to do it. So I will leave that video in the description for your convenience. Go ahead and check that out. Now let's get back to here. This right here, let's write it. Series n goes from 1 to infinity. The idea is that I'm just going to keep the denominator the same again, alright? So let me just write that down. Dot dot dot, and then n plus 100. We want to somehow break this down into just 2 parts, right? The first minus the second. And hopefully they are off by some number k. So how can we do it though? Well, we see that the first factor right here is n, and then the last factor is n plus 100. Wouldn't it be nice if we have the first part right here, maybe just n times n plus 1 up to n plus 99, meaning that we don't want to have the last one here. And then the second part, maybe we can just ignore that and then just do that. So you see, for the first part, I want to have just n all the way from n to here, and then the second fraction, or the second part, I just want to have this all the way to here. That would be pretty fun. And in fact, if we can make that happen, it would be in this form, and they are just off by 1. So now how can we do it though? Right, you see, for the red part that I underlined it, we don't want to have the n plus 100, right? So that means on the numerator, we should have that n plus 100 so that they can cancel. Good. And then if you look at the blue part, we don't want to include the n, so that means we should have the n right here so that they can cancel out. Yeah. And then in the middle, of course, let's put down the minus. That's the setup. And now let's see if we just pair this up, this over the whole thing, then this and that will cancel. We achieve that. Minus, ignore that. This and that will cancel. We achieve that. But the problem here is that n minus n is 0, but we have that 100. Originally, we only have a 1. So what do? Shall we just minus 99? Because 100 minus 99 will give us 1. No, because if you do that, it's going to ruin the strategy. Maybe you can look at this as, hey, this is like n plus 99. If you put that in the parentheses, you can cancel out one of the factors. But no, if you do this like this, no. Yeah, the pattern is going to be ruined, unfortunately. So here's the deal. Now we have 100 on top. don't worry. Let's just go to the front and divide it by 100. So now if you do a quick check, this is still the same as the original. And now we can get to work. Check this out. 1 over 100 is still all the way in the front. And then let me just write down the series as n goes from 1 to infinity. Here we go. First part is this over the whole thing. It's just 1 over from here to here, right? So just 1 over n times n plus 1 times up to what? We don't have this anymore. It's the term before that, which is n plus 99. Good. And then in the middle is minus. And then if you do this over that, n will cancel. So you just have 1 over starting at n plus 1 times n plus 2. And then all the way to n plus 100. Perfect. And ladies and gentlemen, this right here is precisely our an. And this right here is an plus 1. Yeah, because if you look at all the things in the parentheses right here, all the n's, if you just do n plus 1 here, you get this. Perfect, right? So this is so telescoping. And let's just go ahead and finish this the quick way. So here's the deal. This is going to be 1 over 100 all the way in the front. The quick way is this. Because this and that is just off by 1, right? So look at this number. Plugging this number into all the n's only one time. You do not have to do the next number. So this is 1, just plugging into all the n's. So we are going to get 1 over 1 times 1 plus 1, which is 2, of course, all the way to 1 plus 99. So 1 term in the front, and that's the one that we need. And then we also have to come back here and then write down this right here 1 time, just 1 term at the end. So minus this. Just write it down, 1 over n plus 1 times n plus 2, all the way to n plus 100. So what this is, it's just the n's partial sum for this series. But this is an infinite series. So we will just have to go ahead and take the limit as n goes to infinity. And this is so nice because as n goes to infinity, the blue part right here goes to 0. No more, alright? And this is just a constant. So ladies and gentlemen, the answer is going to be, we have 1 over 100 all the way in the front, times, this is what? 1 times 2 times 3 times up to 100. So that's just 100 factorial. So we have 1 over 100 factorial. Aha, this is the answer. And of course, you can put them as 1 over 100 times 100 factorial as just one fraction. But I think this right here might be slightly better. Alright, so that's pretty much it.